Okay, so today we're going to look at the geometric sequencing, the financial application, but we're going to look at it when it decreases. So that's called decay. So remember, geometric means that you are multiplying. The rule is you're multiplying by a number. And because it's decay, that R number, like the common ratio, is going to be a number. It's, well, what we say, it's going to be less than 1, but it's also greater than 0. It's not a negative number. So, but if it's less than 1, you'll end up getting decay. So what we call that is called reducing balance depreciation. So we've got it here, and this is what we'll see on our formula sheet. Now remember, sorry, I didn't highlight this. So remember, if it's highlighted, it means that you will have to put in what the scenario is for each case. So remember, the principal is the original amount, or so initial sorry, I can't spell, amount or original amount. Now, you still have this common ratio R, but what you have to note is that it's a little bit, here's the formula to find it, but it's now going to be 1 minus. So when it was growth, it was 1 plus, but now when it's decay, it's 1 minus. So there's the recurrence relation scenario, and then we also have the nth term rule here. Okay, so let's go through. So remember, we had little r is the interest rate per annum. So maybe we just write percentage rate PA, because sometimes that's generally what they write. They'll say 3.6 PA per annum. And remember, n is the number of compounding periods. So it depends on how long we want to look at. We might be looking at after, 3 times they've added the compounded it, or so on. And then PPY is important on how many times a year. With reducing balance depreciation, just reduce when you've got an item and it's reducing in value, it's not very often that we change the PPY. The PPY is often 1, and you'll see that, but that's okay. If we have a blanket rule for it, we will always do it right. Okay, so let's have a look at these examples here. So a car is purchased for $18,500. So what you, because as I said yesterday, things will get mixed up. So you've got to get into the practice of doing this. So when you read the questions on your test and all that, so I'll put VO because I know that's what it was purchased. And the following recurrence relation. So remember, if you have to write a recurrence relation, remember it has a VO and a rule of how to get the next term from one before. So just to have a look here, we can see that they've got this is our common ratio. That's that big R. So let's just show you how they got that. Because remember, the formula was 1 minus the rate over PPY over 100. So if I did this scenario, it'd be 1 minus the rate, which is 10. Now they're saying each year, so PPY is 1 over 100. And if you do that, you'll end up, you get 0.9. So just to show you, that's how they calculated that. So the value of this car is dropping 10% each year. Okay, now really important, it says use the recurrence relation to find the values after 1, 2, and 3. So just looking at last year's Year 12 exam and the examiner's report on the whole state, they said that it's just not done properly. So that's why I'm saying you need to show exactly what you're doing. So we want to show what V1. So V1 is found by going 0.9 times the one before, which is VO. So we pop that in and we'll get our answer. Now it wants you to show everyone. Now I'm always doing 2 decimal places, even though they haven't told me given me any instructions. Why would I be doing 2 decimal places? Yeah. So Atticus just said, so because it's got, we're doing money, 2 decimal places goes to the cent, and that's the lowest, lowest unit we talk about when we're talking about money. All right. So we got V2. So V2, you have to just show that it's timesing the one before and then get our answer. So you need to have all of them written out because it said to find the value after 1, 2, and 3. So you've got to show every one of those years. So, and then we just do that. So it's quite easy to get your marks for this. It's just, if we're not being, don't be lazy. All right, so then that's the one. And then it's asking us, it said, when will the cars of value first be less than 10,000? So remember, when we're doing these ones, it's probably easier that we just do it on our calculator recursively because we're not too far off. So remember, we pop in the first one, press enter. Then I use the rule. So I say times 0.9 and enter. There's 1, 2, 3, 4, 5, 6. So you can see after 6 years. So at V6, I might just write that, what the price was. So we'll just answer it with when will the car be worth less than 10,000? And we'll just say it would be after 6 years. Okay, so that's that one. So then we've got the next one. A ute is purchased for 53,800. So let's just go VO. The recurrence relation is used to model the value as it depreciates by 8% each year. So just so we know, so we can see that was found. This is the big R. So R was found by going 1 minus 8. Now it says each year, so PPY is 1 over 100, and that's how we got 0.92. Okay. So once again, we're just doing another practice where it says use the recurrence relation. So to find the value after 1, 2, and 3, so V1 equals 0.92 times 53,800, and we get 49496. V2 will be 0.92 times that previous answer, because that's what recursive means. You're just constantly getting the next one from the one before. And then V3, the last one. So they don't make you do too many. So that's probably three or 2 ahead is mainly the thing. And then B, when will the value first be worth less than 30,000? So we could do this again just because we would have already been doing this on to find our value. So just, it's 53,800. Type the first one in. I'm timesing it by 0.92. So 1, 2, 3, 4, 5, 6, 7, 8. So after 8, so I found it V8. So just to prove my point, I say V8 is 27,611.18. Therefore, after 8 years. Okay, so that's just using all the recurrence relations. Now we're going to probably be using the nth term rule. Okay, so let's have a look at that. That's the other rule that we get asked. So here, the following recurrence relation can be used to model. Now, this is where what you're actually going to see in your tests and that, when it's all jumbled up, they're going to tell you that you've got reducing balance. So you know to go to those formulas in your summary sheet. So you go to the one that says reducing balance depreciation, because they'll tell you. They have to tell you. Okay, so they've given me a recurrence relation, so I can see that it was originally 18,000, and here's the rule to find the depreciation. So they're just testing you here on if you can read a recurrence relation. So how much was the car initially worth? Yeah, that's all you have to write. So 18,500. Okay, they're just testing. Now, what is the annual interest percentage depreciation? So what they're actually asking you there is they're asking you what little r is. So remember, that's the percentage rate per annum. So what you need to do is, like, this one's pretty easy, but you do have also in your formula sheets, we've given you formulas because sometimes this can be a little bit harder with other scenarios, with the compound interest scenario, like when you've got growth. So let's just do this one. I'm just going to show you. And the other thing is, with these ones, in year 12, they don't just ask you what's the interest rate. They'll say show that the interest rate is this. So they're pretty much giving you the answer, but they want you to show your working out. So you must, that's why we gave you those formulas, so that you can, if you follow that and just step it out, you'll get the marks because you're showing it. Okay, so you can't what we're saying is a lot of kids, they're trying to get you away from using the solve function. All right, so we've got to work out how to show it. Okay, so we're finding the R from the common ratio. So remember up here, this is the common ratio. So maybe if you want, put that like in that color so you can see. So finding the R from the common ratio in a reducing balance depreciation. So you have a summary of this formula that I'm going to put in. You have it in your summary sheet. It's on one of the last pages. I think you do. If it doesn't, I'll give it to you. So it says percentage rate is, you go 1 minus that R value, which you should be able to see, which we can, and then you times it by the PPY, and then you times it by 100. Okay, now this up here, when they said the recurrence relation, they said this was for in years, so you know PPY is 1 there. If they'd said it was a relationship for monthly, you would know PPY is 12. All right, so in our example, so let's do that. So in the example up here, we're going to find the R%. So it's 1 minus 0.9 because that was the that R value up there. And then we times it by 1 because PPY is 1, and we times it by 100, and we equal with 10%. I know it's very easy to see that, but the reason I'm showing you this, because they're not going to ask in year 12 just what is it. They're going to say it's 10%, show it. So you have to write a formula, yeah? And you have to show that out, all right? So important for that. So get used to just writing that formula out and showing all the working out. Okay, question C, it says write down the rule. So whenever they say the rule, that's when you go to the nth term rule in your formula sheet. So very clear. So you go down there and you realize it says you go Vn, it's R to the power of n times VO. So in this example, your R was 0.9, and what was our VO? 18,500. So there we go. We've written the nth term rule. And then it asks us, it says use the rule to find the value, to find V5. So if I was finding V5, it would be 0.9 to the power of 5 times 18,500. So we could quickly do that on our calculator. So I'm just going to go 0.9 power of 5 times 18,500. Enter. So we end up with 10,924.07. Did they ask me to give a value to something? Nearest dollar. Good. So I'm going to actually just say that one is 10,924. Yeah? Because that's the nearest dollar. And that's probably, they try to make sense. Like, you don't ever go to a car yard and they don't give the sense of it. They just buy it in the nearest dollar. Okay, so then E, oh, sorry, a bit quick. E, what does your answer in D tell you? So they asked me to